Hey there, folks. So, last episode we went through and got things set up so that our NPC would have a reactionary value, oh, hit it instantly, based on the type of creature it sees. So, in this case, we have our pawn, which is a human, and it didn't see anything because I believe. Or did it? Either way, so we set this up so that our NPCs have a get fear response, which is going to be a plus minus value used to determine the reaction that the NPC has. And from that, we need to do a little bit more work and go through and set it up so that the NPC is actually going to run away. So what we're going to do, I'm just going to hop out of this, get rid of that breakpoint, hit continue, and you can see our NPC is, when this decides to actually work and not be laggy, is wandering around the scene. So the first thing I want to do is we need to add in a way to convert what is ultimately, actually I'm going to just change that to response value. We need a way to take this, what is now the response value, it was the fear response, and adjust that based on, or not adjust, but map that to a value to basically say ignore, attack, run away. Ultimately, that's the three final states that we need. So what we're going to want to do for that is we're actually going to want to create a new data type and another enum there. So I'm going to bring up the content browser. We're in our C++ classes project public folder. Right click new class. Leave this on none as always. Click the folder path icon there and select our data type folder, and this is going to be called reaction type. I'm going to create that class. I'm going to hop in. It's going to hop us back here to Visual Studio. And we don't need to do much with this one. So what I'm going to do here, I'm going to delete that there. From delete the functions within the source file, go back to our header and get rid of those. And I understand I'm doing all this while it's still debugging, so it's going to prompt me to reload. E-reaction type. So we want to add the include e-reaction type dot generated dot h, and then it's uenum blueprint type enum class e-reaction type derived from uint8. And this is going to be pretty simple. It's going to be rt underscore flee, rt underscore ignore, rt underscore attack. Meta. Actually, I'm going to grab that so I don't have to type it out again. All right, there we go. I'm going to say reload all. Do we want to stop debugging? Yes. Actually, turn off my speakers so I don't get any of my system sounds. And because we saved it and everything, this reload's not an issue. All right. Now it's going to throw some errors. We're not worried about those because that happens all the time with IntelliSense. Grab that umeta. Just quickly there. Close these two files. We don't need them. So we have flee, ignore, attack. So let's say this is a pretty simple or pretty basic data type, I should say. And actually, I'm going to grab this include here and get rid of these. So I'm going to add that include to our header, our source file for the controller base, because this is where we're going to be doing our function for that. I'm actually going to quickly fix this. Logger get instance add message error level error. All right, so I just wanted to add that in there. So for anyone wondering, just added in a log entry for no valid perception component, because obviously that's going to happen here. So first thing we're going to do though is we are going to create that function, and that can actually be a private function, and we don't need to have that exposed to blueprints. So enum get reaction type. It's going to take a const int reference. What do we call that? Response. Really? It does not like doing that? Oh, I'm an idiot. E reaction type. Sorry, I didn't provide the data type. Constant reference. And just because every now and again while I make these silly mistakes, I do like to bring it up. These are the sort of things that programmers have happen to them all the time. It doesn't matter if they're a newbie who's been doing it for a month, or somebody like myself. I've been doing it for 10 plus years. I can't remember the exact math there. But the whole thing with programming is you're going to make mistakes, and some of them are going to be really silly mistakes. Like right there, I completely spaced on adding in the actual data type it was meant to be returning. So, but with that, anyways, actually this can be a const. So I need to add that in over here, const. What are you complaining about now? Oh, there we go. So we have a couple of different ways we can, let me save please, go about this. My approach to this is going to be, we have our controlled pawn. We have a pointer to that already. So what I want to do is I want to add thresholds to indicate how like afraid or how aggressive a creature is. So what we're going to do there, we're going to go into our NPC character header. We are going to add in a couple of variables here. So what I'm going to do, I'm going to copy this protected one. Int flee threshold equals, I'm going to say -4. Int attack threshold equals +4. Now we're also going to want to add some getter functions to be able to pull these out. So we're going to add in U function blueprint callable blueprint pure, and that's just so these are exposed to blueprints, even though I'm not sure if they're going to need to be. And it's going to be int get flee threshold const return flee threshold. And I'm putting this in the header just because it is such a simple function. Other classes can know about it. It's not going to add a huge amount of compilation time. And int get attack threshold. Const return attack threshold. All right, so now that we've got those, and go back to our AR controller and go if response less than or equal to controlled pawn get flee, we are going to return E reaction type flee. If response greater than or equal to controlled pawn get attack threshold, apparently I didn't have shift pressed, return E reaction type attack, otherwise E reaction type ignore. So this is a very basic function, and the whole reason for this is ultimately, even though you may have very complex AI, you want to try and keep each of the individual components as simple as possible. So now that we've done that, well, we need a way to trigger all of this. So I believe that's the one we want here. So now that we've got this, though, I'm going to minimize get fair response, get reaction type. And just for clarity, the reason why right now this isn't, we're doing an int instead of passing just this through, is I do plan on adding things in, like, okay, if it's extremely hungry and it's a carnivore, it's going to be more aggressive, things like that. So I want to try and pre-plan for that. So it's going to be, we've got an int declaration, and then we're going to add in, like, are we hurt? Are we hungry? Are we a naturally aggressive creature? Things like that. And they're all going to be plus minuses to this. You could, if you really wanted to, go like granular and go for a float for this, but an integer works fine, in my opinion, because it's naturally a keeps the numbers small in terms of a memory footprint in comparison. So a reaction type, reaction equal, if I could spell, reaction equals get reaction type from the response value. Oh, it's because I can't spell response correctly. And then we want key. I believe this is what we want. No, sorry, we want to get the blackboard. No. We do want the blackboard, but that get blackboard asset set key. Okay, let's take a look at our random task we created, which I still need to move into a better location. Get blackboard component set value as. No, let's get blackboard asset. No, okay, what are we doing? Owner comp. Oh, it's behavior tree. Okay. I was in the right place. Blackboard component Nope. Oh, how do I want to do this? Get behavior tree. Blackboard asset. Okay. New Blackboard data. Okay, and then what are our options here? No. Get Blackboard asset. No. Oh, I don't have the Blackboard component on here. That one. Okay, let's see. I think that's what we need. Because that gave us the component. And this is a lot of what you're going to end up doing as well. You're going to be bouncing back and forth, trying to figure out things, especially when it's code or an area of code you're not familiar with. So we want set. I want set key by name, set value. Is that the one? Yep. Set value, reaction state. Reaction type. Sorry, reaction. Think. That's going to complain because that's not right. Okay, how do we do that? You're expecting a T data class, F data type. Oh, I see, it's a templated function. Is that right? I think this is why I had in my notes set it as an int map, because it yeah, so this makes sense now. Why I had it as an int map, because moving this to the set value as int, so selected, what was that called? Get selected Blackboard key, that's it. Okay, so I'm going to actually change some of the stuff I've got here. Why are you not? What Blackboard? Behavior tree. Blackboard component. Okay, where are you getting defined? So that is behavior tree tasks, BT task, Blackboard base. There we go. All right, so what I'm actually going to do here, we're going to go to our definition. We're going to try what I mentioned last episode about casting these to an int. So 0, 1, or 2. And actually, yeah, 0 fleet. 1, 2. Yeah, we'll do that. 0, 1, or 2. And we'll go from there. So int reaction. Is that going to work? If I could spell. Why are you saying identifier gets selected? What? It's right there. No. Okay, so I guess we have to do this by name. So reaction value. Okay, so I'm going to get rid of that there. Let me save. Thank you. Okay, so we're going to try a build here quickly. Now this, I can say it's very janky. Really IntelliSense. Let me save. Okay, so we're going to try a build here quickly, and we're going to see if we can get this to correctly apply to our behavior tree. With that, though, I'm going to pause the video here, and I'll be back once we're in the editor. All right, folks, so we did have a build error with our reaction type here because we used that forward declaration. Let's see, is that going to throw another error because we don't have it in the header, or is it just going to accept that? Just in case, I'm going to pre-prep, and we want that one there. Yeah, it's going to throw an error. So, all right, build cancel. We're going to cut this from there. And this is some of the things where, yeah, that works in some cases, but not in others. So let's add that in there, and that should do our build. So this go around, it should be pretty quick because it is just our AI controller base we're making changes to, which, what are you throwing an error about? Oh no, there we go. All right, well, in the interest of time, I'm going to pause the recording, and we will be back once. Why is it building that? We'll be back once we're in the editor. All right, so we're back in the editor here. What I'm going to do is just open up the behavior tree for our NPC, and we're going to start work from there. And as always, it works opens up in the other monitor. So right now we have the sequence node, which is just going to do our go through, but what we want to do is add in a selector here. I believe it's selector, actually. Actually, first thing we need to do is actually our behavior Blackboard. We need to add in that key. New key. It is an integer. And we're going to go copy that out from what we put in there. That is the reaction value. And set that. So what we're going to do first and foremost is actually make sure that that works. So I'm going to hop back in here. We're going to throw a breakpoint where we get our reaction type, and then we're going to play an editor. All right, so yeah. Okay, so now that we've got that, hit continue. Actually, let's get reaction type response value. So a breakpoint there. Continue. We should see this again. Where'd you go? And it is being very laggy all of a sudden. So let's pause and find our NPC. I'm trying to remember how we pull up the AI data for that. No, that's not what I wanted. All right, give me 1 second here. I want to just figure out the best way to actually, don't want that selector. Blackboard. What do we set that to? We want that to be 1. Okay, yeah, sorry. No, I'm looking at my notes here and I've got this figured out. So, okay, so we want this is equal to 1. Reaction state. And we want to give that a default value, actually. Default key type int does not have a default value. Yeah, so by default we want it to be set to ignore. Now this is obviously just the early stages, because once this is set, there is not going to be anything to set it back. But so going back to our behavior tree. So yeah, now, sorry, I was looking at my notes. I was a little jumbled on this because my chicken scratch in my notes. But so what we want here is our selector. And the reason being for this is basically this is our default if we have nothing else to do. And what we want to do here is on result change, observer aborts self, because this is the lowest priority. What we want to have here is I'm just going to put some selectors in here and name them so we can. This is going to be our attack behavior. And this is going to be our flee behavior. So the way this is going to work is we are going to, actually this should these should be sequence nodes. So let's select that one, idle. Okay, we're just going to finish getting these set up and then we'll end the episode. And next episode, we'll actually get the next phase of these. So this is going to be the attack. And this is going to be the flee. So we'll add these decorators in that we want. Add decorator, blackboard, select the decorator. We want to abort both for these two. Blackboard key reaction value is equal to, this is 2. Yeah, 2 is attack. Yeah, and 0 is flee. Okay. Add decorator, blackboard, select that. And 0. And this is, again, we want it to abort both itself and any lower. So what that'll do is it's going to, okay, if it's equal to 2, we're going to attack. If that changes, we're going to reevaluate. If it's equal to 0, we're going to flee. If it changes, we're going to reevaluate. And if it's equal to 1, well, we're going to just wander around. And if it's not, if that changes, we're going to stop and reevaluate. So With that, though, folks, what we are going to do here is end the episode. Next episode, we're going to set up the functions for our flee behavior, and that's going to be finding a point away from the target. And we are also going to then have, well, it's just going to be the move to. And then, but at the end of that, once that move to is complete, we're going to reevaluate. And that's where this reaction value is going to change. So anyways, folks, thanks for watching. As always, if you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Thanks again, and I will see you in the next episode.